This is the EdExcel P3 chapter review. I'm just going through sort of a little bit more detail going through these questions. You can check it out on Solution Bank to check the answers. So I'm following the Solution Bank. Some of my students, find the Solution Bank quite helpful. Others find it a little bit limited sometimes. So I just want to make sure that a full sort of mark scheme is available the way I do these things. Okay, so 3A has a function divided by a function. So if you were to look at this, it has this restriction, x larger than 0. That's just because x is in the denominator. So obviously it can't be 0. It has to be bigger than 0. The mark scheme suggests to use the quotient rule. So the quotient rule is u dash v minus v dash u over v squared, where u is the top function. So this is u and v is the bottom function. So you could do this, and that's the suggestion. There's nothing wrong with it. But I very seldom use the quotient rule for these sorts of questions. What I do is I rearrange them and I use the product rule. So I always use the product rule. So just to show you that this can work, the way to use the product rule is to just make this x to the minus 1. So if we had the product rule, we would have u dash v plus v dash u. And it's just easier to remember this way. So if we let sine x be our u and x to the minus 1 be our v. So u equals sine x, v equals x to the minus 1. And then u dash equals sine x becomes cos x, positive, and v dash becomes negative 1 times x, and then this minus 1. So it's minus 2. Okay. U dash v goes this way. U dash v is x to the minus 1 cos x. So x to the minus 1 is just 1 over x. So we could just say, for example, dy dx is going to be cos x over x to the minus 1. So cos x times x to the minus 1, sorry, it's cos x over x. And then we want v dash u. And that, again, negative x to the minus 2 is just 1 over x squared. So we could say that's going to be minus sine x over x squared. Okay, so we times v dash u. So this doesn't look like the mark scheme yet, but so to make it look like the mark scheme, we could just use a common denominator of x squared. So times this by x over x, and we end up with common denominator of x squared. It'll be x cos x minus sine x over x squared. Okay, so that sorts out number A. Let's look at number B. Number B, common problems. So when we're differentiating, the way that they've approached this one is they took the function that was given and they split it up. So using log laws, for example, if you had ln a over b, that would equal ln a minus ln b. So we're using this log law. If we apply it and just rearrange this a little bit, we end up with ln 1 minus ln x squared plus 9. And ln 1 just equals 0. So we actually just have ln of x squared minus 9, and it's negative. Okay, so this is the function that we need to differentiate. This is the function we need to differentiate. So they just rearranged it to make it easier. That's one way to sort of look at this. So we want to know what dy dx is. What is dy dx from this? Well, if you have a function y equals ln x, then our dy dx will be 1 over x. So you take the x to there, but our x is a whole nother function. Our x is a whole nother function. So we, in the place of x is just a whole nother function. So don't forget that it's kind of like a chain rule. So you have to times it by the first derivative of that function. Okay, so if x is a whole function, I could write it as 1 equals ln f of x, for example. And then our dy dx would be 1 over the whole function times by the first derivative of that function. Okay, so this is kind of the one we're going to apply. Just get that moved over for you. So this is what we're going to apply. And our f of x is this pink thing. And then f dash of x would be the first derivative of x squared minus 9. So x squared minus 9. The first derivative would be 2x. And obviously the 9 just be 0. So it's 2x. Okay. So what we get is dy dx is equal to, that negative just comes down, it's the a value, ln of the whole function times by the first derivative of the whole function, which is 2x. So if we simplify that a little bit more, we get, oh, excuse me, what did I do? It's not ln, it's 1 over. Okay. If we simplify that a little bit more, we get 2x, because timesing, over x squared minus 9 is our dy dx. And that should work. So just to recap, that's a version of the chain rule that we've used there. Color, there's our f dash of x there, and then our f of x underneath there. Okay.